Up next is John Hamilton. John is the Chief Operating Officer of the Testing, Adjusting, and Balancing Bureau of the National Energy Management Institute. He serves on the SMACNA SMWIA Task Force, HVAC Technician Certification Committee, Commissioning Task Force, and he's a liaison on the International Certification Board for TAB. He has given numerous IAQ seminars and workshops for AIA, ASHRAE, CSI, SMACNA, and others. John holds numerous certifications in the HVAC field and teaches several courses within the field. He received his BA from Baltimore University. Please welcome John Hamilton.
Well, thanks everybody. I appreciate the invite. This has been a very rewarding seminar for me to attend. As you can see from reading the synopsis, I believe this is the first presentation on air for the last 2 days. And it's been neat to learn about the water industry, and I never realized how closely we're tied together with the water industry and the air industry. And a lot of the things I'm going to touch base on today are directly related to the water industry, the air industry, and what we need to do to make things more efficient. First question people will ask a lot of times is, who is TAB? TAB's a nonprofit organization comprised of SMACNA board members, Sheet Metal Workers International Association members. TAB sits on ASHRAE technical committees nationally. One of the things I'd like to touch base on right off the bat is we do also do some research with ASHRAE. We did quite a bit of research. I don't know if you've heard of underfloor air distribution systems. They had made they were quite popular 3 years ago, and through some national research and partners, we were able to show, along with the federal government and GSA, that some of the UFAD systems they were installing were costing 300% more to operate those buildings, energy costs, but guess what? They were green. You know, and it was the first time it stuck it out to me, maybe we need to look at green and what do we need to do to make sure green's working and things are more efficient. The latest thing that they've actually tied together, and I'm going to be able to piggyback on some of the things I've learned here this week, is ASHRAE Research has done some extensive research on flexible ductwork. And I'm sure everybody here knows what flexible ductwork is, whether you have it in your home, you've seen it in places. And when they went through and they did this research on flexible ductwork, I didn't realize that they showed that flexible duct increases water usage in a building. And I learned that from this symposium this week, because if energy costs and energy use goes up, water usage goes up in the building as well, right alongside of it. So if we can save energy in the buildings, I can see us decreasing the water use in the cooling towers and everything else. So I will be adding that to part of my presentation when I talk on the with the air side and the air people, and when I'm sitting on my ASHRAE committees. And basically what the executive summary in 2 lines on this flex duct study, what it says is, if you use 6-inch hard pipe and you want to run hard flexible ductwork, you have to increase the size by 4 times. Exactly. That's exactly what I did when they went through. And ASHRAE spent $500,000 on this study. And it used to be in the field, people would say, make it 1 inch bigger, make it a 2-inch bigger. And lo and behold, when ASHRAE went through, they said, how did we come up with these numbers? And they said, well, you stretch duct and put 10 pounds of pressure on each end of it, and then you see how much resistance it creates. And that's not the way it's installed. So the real-world testing of it said, you need to put in ductwork that's 4 inches bigger. If you run an 8-inch hard pipe, you need 12-inch flex. And then they went and they said, let's see what happens when we use that flex and we come down 90 degrees. And they found out that a 90-degree flexible elbow is 12 to 20 times the resistance of a metal elbow. Now, when we talk about the balancer coming in, what this presentation's about, we always wonder why we don't have enough air coming out of the end of the ducts and out of our terminal devices, and they all are hooked up with flexible ductwork. Wow, I wonder why that is. So this study shows a lot of the things, and it's going to be neat to see how this is implemented in the green code, in LEED, and in building codes across the country. Another thing TAB does is we work with the American Institute of Architects. I don't know, in my area of the country, occasionally on construction projects, the architects want to say you don't have enough room for that. And we say less room equals less efficiency. So we're always working with AIA to say, how do we make the buildings how you want them to look, and how do we keep them efficient? Construction Specifiers Institute we work with, sit on some things with Construction Specifiers Institute to help write the national specifications, master format, where things should be. Association of Energy Engineers we work with, and the National Fire Protection Association. We have employees that sit on those committees as well. Now to start, I like to ask the question right off the bat, why balance an HVAC system? Why do we need people to come in and adjust our valves? Why do we need this to happen? Well, when we come in and we say, what's the real need for balancing a system is, I wrote an article that was in a national publication, and the editor got quite a bit of feedback, and I got quite a bit of feedback, because I made the statement that said, because we engineer things wrong. And people started sending in, what do you mean we engineer things wrong? And we do it on purpose. Is if we come up and we say we need a 7-inch pipe for air to go through, we automatically round it up to 8-inch. So we start putting in the wrong size. If we engineer something for hydronic flow and we need a 5/8 inch pipe to carry that many GPM, do we put in 5/8 inch pipe? No, we put in 3/4 inch pipe with a balancing damper on it so we can adjust it so it mimics the resistance of 5/8 inch pipe. So I like to say right off the bat, we're typically installing the wrong size stuff on purpose. And that's why we need to bring someone in to do the balancing work, to make sure that we're tuning it so the system works as designed. Then I like to touch base and say what else happens is you say, well, we need to get a boiler in the area of this hotel that has 98,000 BTUs of heat. And we go to the catalog, and as engineers, you don't go to the catalog and say, oh, I'm going to order one that's 98,000 BTUs. You look at it and you say, there's one that's 75,000 BTUs and one that's 125,000 BTUs, and which one am I going to put in? Typically they oversize it so that we're not stuck on our design days and it wouldn't be meeting the need. So the first thing we did was we put in the wrong size duct, the wrong size pipe, and now we're putting in the wrong size unit. And we wonder why, and to get that need of why we have balancers go out and do all this adjusting to tune these systems so we can get our energy efficiencies and our cost per square foot down on what it takes to take care of it. That's some of the limitations put on the HVAC systems. And then we have the architects as well saying you don't have enough space. Some other things that can have effect on balancing these systems is it perfect? In the area where I live, occasionally what is installed looks different than the drawing. You look at a blueprint and then you go out to the job and you say, how can this look so different installed as opposed to what we have on the print? Well, we did creative stuff throughout the process of saying, hey, we can value engineer this, we can change that, we can pay it back. I like to talk about life of the system. Even in the insulation program we heard about earlier there's a 50-year payback on insulation. And you look and you say, that's in today's dollars. And most likely that building's going to be standing for 80 years. But even if we're just over half of the life of that building, it's still not worth putting in the insulation. To me, that just seems crazy. And that's the benefit of all of the codes. Some people complain about codes, and I always shake my head and say, where would we be without minimum standards? We'd be a third world country. because people don't want to do it if there's a 5-year payback. And here we're saying we know the building's up for 80 years, the insulation will be paid for in today's dollars in 40 or 50 years, but it's not worth doing. And that is the common way of looking at things right now. That value engineered has a different saying for a lot of people. I remember the first time I heard the term, I walked out onto a job site and I noticed these big green pumps. And I'm going, what the heck? Something just looked wrong. You know, when you have these 4 huge green pumps in a smaller building, I'm like, something's wrong with this. So I asked the project manager, I go, his name was Guy, I go, why do these pumps appear to be so big? And he goes, John, he goes, we value engineered it. And I go, well, what do you mean? How did you value engineer it? And he goes, the price of copper doubled this summer, so we put in half the size copper pipe, and then we just put in bigger motors. And this was his way of value. He really thought he was value engineering it, as opposed to saying value engineering it for the good of the customer in the long-term use of that building. So you have 2 extremes of what value engineering is. So we talked about this, you know, you can't get what you really need for equipment. Your pumps are the wrong size, your fans are the wrong size, your ductwork's the wrong size, and your pipes are the wrong size. So you need to have someone come in and balance it. Then the next question is, how do you come in and balance a system properly? And I like to bring up the term proportional balancing. I'm going to talk about what's needed to get done properly, system effect, and the difference between piping and air systems. There's 2 basic methods of balancing an HVAC system. Proportional balancing, it's the preferred method. It's taught at over 165 training centers in the United States and Canada. It's what our technician exam is built around. Then there's the sequential method of balancing a building, and I used to do some sequential balancing when I was younger, and that is basically by guess and by golly. If I adjust this, what happens? No math, no reason. And I like to say that's how many people used to fix their automobiles before the advent of all the electronics. I like to say if you sequentially, if something was running, your car was running wrong, there was a sequential list you would go down. The first thing was you'd adjust your points, condenser, distributor cap, spark plug wires, and they had a sequential list. And when you magically fixed what was right, it worked. And you may have replaced 3 things that you didn't need to, but we got down and they fixed the problem. So that's the difference between the 2 methods. Proportional balancing, and the importance of this and how this all ties together is when we start talking energy efficiencies. Is when we say this, all systems being balanced shall have the least amount of restriction being imposed on the system. It's a lot to say in one sentence. And when we look at it and we go over it, we are saying all systems being balanced shall have the least amount of restrictions being imposed on the system, meaning we don't have too many dampers turned down. Associate it with punching yourself in the face. At one point, you start hurting yourself instead of helping yourself if you start having too many dampers or valves closed where the pump or the fan has to push against more resistance than what's needed. And with sequential balancing, that's usually what happens. At least 1 outlet damper on every branch damper shall be fully open is one of the rules. At least 1 branch duct damper shall be fully open for every trunk duct, and for every trunk, 1 damper needs to be open. Basically what it's saying is from your pump or your fan, you're going to be able to follow the fluid, whether it's hydronic fluid or air fluid, all the way to the terminal device, and there's not going to be any restriction on at least 1 of those. And that's what a commissioning agent should be asking for when they come out to commission a hydronic system or an air system. Instead of randomly grabbing 10% of the diffusers or 10% of the coils, they should be saying, show me where you have a loop that doesn't have any restriction and the damper is 100% open from the pump to the terminal device. Then you know you're putting the least amount of resistance on a system. The idea behind this is once you set two valves or two dampers in the same position with the same flow ratio, no matter what you do to the rest of the system, those flows will vary together. When we adjust damper number 3, after we've set 1 and 2, they rise and fall together proportionally to each other. That's where the term comes from. So we set it and we keep working our way right down the line for that. Even if the total system flow changes, they still remain in proportion to each other. Advantages, it's based upon laws of physics. Each outlet is balanced once. Minimum times required. All systems that will be proportional balance will be delivering the air or water with the least amount of resistance. No other method imposes less restriction on the HVAC system. Minimum noise, because if you can imagine when you start cranking on dampers and valves, we immediately start saying when we put too much on and we build a static pressure up and velocity pressure is going down, we start to generate noise. Minimum horsepower is required. Minimum fan RPM is needed. One of the things that I see happening more and more today that never used to happen, it was always just in the books, and I do have to say is happening because people want to be more efficient, is we used to never trim the impellers that often on pumps. We could calculate it. The balance report would come back and say you have an 8-inch impeller. If you trim it back to 7 5/8 inches, it'll run, it'll deliver all the water you need or the hydronic or the glycol. And this building will save X, it'll pay for itself basically in about 6 months' time. But no one took the time to say what they would do is it'd say, well, let's put a valve on the discharge of the pump, and we'll just have it work against that for the next 80 years. And you're laughing because I imagine you've seen this over and over again, and you shake your head at it. And really what it did was it helped out the VFD world because they could come in and say, hey, we can control it with speed instead of, and we'll actually finally do something about the issue or the problem. And burn a lot of motors out in the process, exactly right. From not just trimming the impeller, it's working against yourself. Some of the other advantages, it's the lowest energy consumption you can have if it's proportionally balanced and you follow those rules. The HVAC system is under control. Adding more ventilation air will be delivered through the entire system when we're talking bringing fresh air into a building. The system can be brought up or down. Now this is where we have an issue, and I have seen it happen over and over again where when they bring in commissioning people to come in and commission the hydronic balancing or the air balancing, the commissioning agent comes in and says, I have a checklist, and my checklist says that that needs to be at no less than minus 10%, and that one's at minus 30%. You need to make that one right. The only thing the balancer can do is go and put more restriction on other dampers, throttle those dampers down. As soon as he starts throttling other dampers down, the static pressure starts going up in the duct system. Static pressure goes up, velocity pressure goes down, we have less flow. So we have a higher static and less flow. Then the balancer comes back and says, now our whole system is down to 90% flow. Now we need to replace the motor on the fan and put a new shiv on the fan and speed the fan up. And you say, and this is coming from the commissioning agent that's there to help the owner so they get a good product in the end. And they just cost that building owner X amount of dollars by increasing the static pressure in the duct system. It's imperative that the commissioning agent is an industry expert so that they can recognize what to do in those situations and look and say, you know what, we're in this big room. Yeah, we don't have the plus or minus in that one back grill. We're at 40% of flow even if it's terrible. You know what, in that area we can increase the other ones 20%. So it's given more than design. So in that area or zone of the building, we're given the proper amount of air to meet design. We've released some static pressure out of the system to put more air in there, and we've actually made the system run against less static pressure, deliver more air, and be more efficient. And you don't see that happening with commissioning agents. I have a son who's making a career choice right now, and he's looking at the construction industry, and I told him, I said specifically, I said, Matt, if you're going to get involved with civil engineering. Do not get involved in test and balance. Test and balance is at the end of the job where the schedule's compressed and they want you to fix everything. Get into civil engineering where you'll always be around those big scissors with the ribbons and the shovels with the spray paint on it with the gold. I always picture the spray paint cans laying off to the side of those pictures. I always go, I wonder how far away from that gold shovel, because you can see it at the last minute. Someone was spraying the shovel right before they did the photo op. And I go, I wonder if they threw it 8 feet away, 12 feet away, or if they're picking it up on the way out. But I said, get involved with civil, because if you get involved with this balancing, you're at the end of the job, you have a compressed schedule, and for some reason, the industry and the engineers come back to the balancer and they say, balance it, fix it, redo the balancing report. And you're like, this guy didn't design the job, didn't install the job, but he's supposed to make up for the deficiencies. And I like to compare that and say, that's like bringing in your automobile to your mechanic and saying, I need 50 more horsepower out of my Chevy truck. And he says, well, I didn't design it, I didn't build it, I can only tune it to how good it's going to be. But for some reason, this onus falls back onto the balancing agent. Then when the balancer says we're short air, and you have a commissioning agent, and they've run a half-inch pipe that's supposed to deliver 5 GPM of water at the end, and they have 172 elbows in it, and they've had to go up, down, and all around, and they say, we can't get the right GPM out of this half-inch pipe. And you'd say, you know, the right thing to do would be to tear that pipe out and install the right size pipe for the life of the building. And I ask, how often on a commissioned job do you see them tearing out any hydronic piping or ducts at the end of the job so that it's done right? Doesn't happen. And until that starts happening, I'd say, is the commissioning process really working? Scope of work, I like to talk about this. We talk and the balancer comes in and says, what are we doing as the building balancer? They do not come in and say, are all the HVAC systems working together? This hotel is a great example. If you come down the hallway and you feel a rush of air coming towards you, the first thing people would say is, this building's not balanced. But when the balancer came in, they only did it to design specifications. They don't take into consideration if the engineer said, you know what, this is a windy area. Most of the time we're going to have a 20-mile-an-hour wind from the northwest. As it's hitting the building, I want to pressurize this side of the building. So the balancer never really looks at the entire building and says, I'm balancing the building. I'm only balancing the terminal device and what's on the design. It's individual systems within specified tolerances is all the balancer is doing. A good example is one might be 9% high, one might be 9% low, and you have an 18% difference, and that would explain the 20% air that's flowing into your face when you're walking inside a building. Like, why is it so windy in here? They don't worry about that scope. They're only balancing to those specifications, to those systems. I like to ask, and when I do presentations for ASHRAE and the engineering community, how much more horsepower is required to move twice the air through the same duct, or for this crowd, twice the water through the same pipe? Since this is after lunch and we're on that carbohydrate thing, this is out of my Dale Carnegie course where it says get the crowd involved, like at the 15-minute mark. So this is a question I'm asking of the crowd. Does anyone have any idea how much more horsepower is required to move twice the amount of water through the same pipe? Crickets. 8, exactly right. That is exactly right. It's 8 times the horsepower. So when a commissioning agent says, on that same half-inch pipe that's only delivering half of the flow and says, as a balancer, you need to make it work, they're really saying throw 8 times the horsepower at that half-inch pipe. And when you start looking at it like that and you say, I'm going to start using 8 times the energy and the commissioning agent's making me do it because they don't understand the system, what kind of trouble does that lead to for the customer or the end user of that? Its energy costs are higher. Do you want to sacrifice a whole system for one outlet? The commissioning agent, if it's checklist commissioners, they do. One of the things that we use in our industry quite a bit is this paper calculator, and these affinity laws are right on the back of this calculator. You can grab them off my table in the back after my presentation if you want. It's the third affinity law, which brings us to the next one. Is this works the problem out to say on the bottom, that's the exact third affinity law of how we come up with the new brake horsepower that's required. So what happens is a balancer will go through the building and they'll balance the whole building and they'll say we have a couple bad outlets, a couple bad terminal devices. They might get thrown back at them, you need to rebalance this. Well, if they really did proportional balance it, the only thing they can do is increase the static pressures in the system and then come back and say we need a larger pump, we need to spin the pump faster, we need to adjust the VFD so that we have a higher limit on it. And as we know, the amps go up on everything and the energy costs go up on everything. Well, value engineering, ring a bell to anybody? I mean, how did we value engineer it? To me, this is the opposite of the original value engineering I talked about. The value engineering here is for the consumer in the end to say, how do we make this better and his energy costs go down over the course of this building? This is where the value engineering comes in, where the commissioning agent should be the person saying, let's take some pressure off the system to solve our problem. And if they're saying you need to put more pressure on the system to solve the problem, they're only increasing the energy costs. And then you look and say, well, if the balancer doesn't have the integrity and is not really balancing and they're doing one of the pencil whipped reports or bogus balancing report and they put down the numbers people want to see, they don't get in any trouble. They just accept the report and people move on until there's a problem, until someone's not comfortable. So that's the importance of doing it right. If an HVAC system is proportionally balanced, how can more air or water be delivered to the key outlets without adding energy costs to the system? I'm not aware of any way to do it without changing the system. You cannot deliver more unless you increase the static pressure. You can take static pressure off by replacing and resizing the duct or changing the system, but otherwise it's only going to cost more energy. One more real world problem that I have is I like to look and say if we have a 6-inch duct delivering 55 CFM and a design says 100 CFM, we took our static pressure inside the duct and it was at 0.18 inches. I like to calculate what the new static pressure is to deliver the proper amount of air. And that's the second affinity law on our little paper calculator. And what that does is we say that static pressure new equals the old static pressure, that 0.18, times the new CFM divided by the old CFM, and you square that. So as we work through the problem, there's our math, we come up with the new static pressure, we multiply that, and that's going to give us our new static pressure of 0.59 inches. So what we started with was 0.18 inches of static pressure in a duct. The commissioning agent came along and said, that's reading too low. What I need you to do is increase the static pressure in that duct up to 0.59 inches. and when you look at it in energy and you look at it in these terms, it's craziness. It's crazy to ask someone to do that to the system, because the energy cost is out of control. What we would do is we would look at that and would say, if that's really your issue, we need to tear the 6-inch duct out. And can you imagine if this was that flex duct from the study earlier? All they'd have to do is tear out the flex duct and put in a hard pipe, and they'd get their amount of air. With this, you'd look and say, you know what we need to do to that 6-inch pipe is we need to tear it out and put in 8-inch pipe. And then you throw that on to where we are with the balancer at the end of the job. Everybody wants to move on to the new one, and the balancer comes up to the commissioning agent and says, what we really need to do to that 6-inch pipe is we need to tear it out and put in an 8-inch pipe. And it only goes through 3 firewalls. And we need our certificate of occupancy next Wednesday, because that's what the schedule says. But what should the commissioning agent's job really be? Yeah, it's a hard hurdle. In the engineering, we might have missed it. And I think I was on 1 or 2 jobs where the plumber messed me up because they had like a big rainwater leader or something. They said, I need to move my duct over. Yeah, we'll meet outside, me and you. Yep, because I've been waiting for a guy like you. Occasionally, they'll get in your way, and you'll have to move something that's different than the drawing, and we lose. So we move this. So it changed the design. And it should be, I mean, you can see why there's problems. But the right thing to do is to tear it out, put in the right size duct. If it's critical, a lot of times we see these in fresh air applications going to the backside of a heat pump. They run 75 feet of pipe, 15 elbows, and they say, why are we short on fresh air coming into the backside of the heat pump? You know, well, we need to tear it out and put in 8-inch pipe to do it properly. Otherwise, we have these energy costs where we're ballooning it up, and then we start saying, well, we have duct leakage in there. We start getting into higher pressure classes of duct systems. Do you want your commissioning authority to direct your balancer to do that? Cost of not designing a system properly, of course, is 24/7, 8,000 hours per year. Would duct or pipe replacement costs be worthy of the long run? It's really up to the commissioning agent. Use a balancing professional or the balancing industry to make the best possible running HVAC system. I really think that's why you're not seeing the cost per square foot of new buildings be that much lower of older buildings. I mean, as an industry, as an HVAC industry, we really have to almost be embarrassed that with all of the technologies and all of the things we've come up with in the last 15 years in HVAC, the operational cost should be going down tremendously per square foot. And it's not going down anywhere close to the claims of what it should be going down with. And a lot of it is because of other things we've added to the system as well. You know, I've seen it over and over where bad commissioners come in and increase the cost of operation. I like to talk a little bit about ANSI. ISO 17024 is an international standard for certification bodies that eliminates conflicts of interest. Future competitors aren't judged by existing contractors. It follows an international certification standards. Makes certification bodies adhere to policy. ANSI actually comes into our office, audits our files, audits our folders, and makes sure everyone's getting treated the same and everyone meets the standard that we've set. TAB has an integrity agreement. All technicians must sign. Certification can be revoked for falsification of reports or misuse of the TAB agreement. I like to say that because I get calls probably at least once a month from technicians around the country that say, my contractor wants me to lie on a balancing report before I stamp it. What should I do? And I always say the only thing you can do is report what you really have and stamp your report, because it's your integrity behind the certification to make sure that these people are actually getting the right data, the right numbers, so that they can proceed and do their engineering properly off of theirs. Some definitions I like to say is, of course, adjusting. Adjusting is just varying how much flows going through pipes and ducts. Proportional is it's proportional to each other. And testing is using calibrated instruments, which was required of the contractors when they get their certification. And with that, I believe the next slide is the thank you slide and the call for questions.
Hi, my name is DJ Nunez. I'm on the board of directors for IAQ, and I am a mechanical inspector for the state of California. I take it you're not real huge on the commissioning authority.
The commissioning authority can be a great tool if done properly.
Oh.
When you get to checklist commissioners and people that are coming in from outside the industry with a checklist who don't understand systems, don't understand the balancing procedure, those are the people that are adding costs. If you hire, or if they bring in someone else who's a balancing contractor who understands system costs and how it all works, the commissioning can be a great tool to be used.
Well, working for the state, I'm pretty much the liaison between the commissioning, third-party commissioning that's required for leads, certifications, and the contractor. So I don't use them so much to pick apart the balance and stuff, but where we do utilize them is systems integration for the building management system, and tying all that in together. And they're a big help because, the control side of this is above and beyond my head and most anybody out in the field's head. So that's where we get the value with our commissioning authority. But my question to you was, part of my job is to review the test and balance report. And these areas you talk about to where you're not within the 10% plus or minus. Our state spec says 5%, but on a design build, they get it back to industry standard, which is 10% plus or minus on your CFM. But where you're talking about an open area that you might be 40% low in one area, so you increase it. But the problems that we have is when you have individual office spaces and you're not getting that desired CFM, you have problems. You have 55-year-old women going through menopause. I mean, I'm constantly getting called back because she's hot or she's cold, and he's hot and he's cold. And these are the areas that's frustrating for me because you're not if you can't get within the 10% plus or minus, what's the use of having that as an industry standard if you're going to be 85, 90 CFM low in one room and 100 high in the next?
That's a great question. I should have been more clear. And what I was saying was when we have a large open area like this, there's certain applications where the balancer can say, you know what, in this ballroom, that one linear diffuser in the back corner isn't going to matter as much, but your application where you're saying specific for an office or a cubicle, it has to be within the plus or minus 10%. And then that's where we look and say, is duct replacement, or do we sacrifice the system to get the right amount of air for that person?
You're spot on there. At that point, nobody's replacing anything because A, there's no room up there at this point, and everybody wants to get out because you're looking for that certificate of occupancy.
Exactly right. And I'd like to chat with you after if we could. I actually work on some of the CEC stuff and actually worked on some of the MEC forms and helped develop some of the MEC forms you're going to see coming down the pipeline.
Great. Thank you.
Thank you.